Hi everyone. We're carrying off on an experiment from last week where we had the hello world, except we're using it for measuring temperature. A lot going on. And here's proving measuring temperature. And I have a thermistor right here. When I touch it, it can change with the temperature of my finger. So you can know that's working. It's degrees Celsius. We have blue as the comm lines again. We have the enable, I believe the green and orange is a reset, or the other way around. I get confused. We have multiple places where power in red is being hooked up, and here is a resistor kind of acting as a negative temperature coefficient transistor that's used in temperature circuits such as this, and this is a thermistor. And again, the red is all daisy chained to a central place, and then it takes a little hop over here. This is for your resistor where it's, well, I'll get back to that in a sec. Your grounds are all daisy chained and they're all brought over here. So that makes things a lot easier. I have my variable resistor over here where I can change the contrast. And going back to that white wire, that mysterious white wire, we'll go down to it real quick. There you are. Okay, right here, you need something to go to the analog. That's where we're getting the information for the temperature change. But that's not the only thing giving us information. It's the program running too. So a resistor is basically a thermistor is basically a thermal resistor. Resistance changes, but very minute and small depending on the temperature. So it will affect how your resistor perform. You have a negative temperature coefficient resistors, which are used for temperature circuits such as this, and positive temperature coefficients that kind of act as fuses. They protect your circuits, and they're very effective. So it's good. From my own experience, there's power resistors too for higher wattage. Anyway, let's move forward here, shall we? So you can see there's a lot going on. I'm not going to get into everything, but a lot of wiring, a lot of figuring out. I hooked some wires wrong. I had to figure out how they went. So, okay, here goes the code. That's what we want to get to. It explains how the liquid crystal display, the comm lines, those have not changed. Then it goes into the math with the programming combined, where they figure out the formula, figure out the temperature. And that's done within the programming. Here's some more of it. And it also compensates, not as temperature changes, not always the numbers are the same. Sometimes it's a whole number. Sometimes it's not improper, but there's some numbers leading after the decimal, floating number maybe. Anyway, my math is a little off, so you can set the math police after me. That's fine. I'll just change my address. Anyway, it's kind of interesting. Now I'll go to the program here. Like I said, you have all the temperature math in there, figuring out, because it does it while you're going. But you also have to get in your library, and you have to add the liquid crystal display. Now, that's up here. I've explained how to do it a number of times. I'm not going to do it again, but needless to say, at first I had this working wrong because I couldn't get the wire. I had the wiring in the wrong places. That's why it's good to have some magnifying glasses, and it's good to have a static wrist strap on your hand to protect your circuits. While you're seeing the display, you see that light. There's and I showed you the contrast earlier. That's how you're able to read the temperature off there. That's all I have to add, but a lot going on. So everybody have a real nice day. Take care, be safe, and enjoy yourselves. Bye.